Hello there, and welcome to The Sleepy Scholar. Tonight's journey takes us into the vastness of cosmic scale, to the majestic and glittering world of the Milky Way. Long before we understood what it truly was, our ancestors looked up at the night sky and saw a faint, glowing band of light stretching across the dark canopy of the heavens. They called it a celestial river, a majestic pathway for the gods, or a stream of heavenly milk spilled across the firmament. It has been a constant, silent companion to every quiet night in human history, a reminder that we are part of something unfathomably larger than ourselves. Tonight, we do not just look at this band of light. We realize that we are deep within it, drifting peacefully in one of its quiet outer arms, held safe by gravity as we journey through the endless dark. To explore the Milky Way is to sail an ocean of 200 billion stars, each one a lonely island of light in the grand archipelago of our galaxy. It is a place of quiet nebulas where new stars are born from sleeping dust, and ancient clusters that have watched the galaxy turn for billions of years. As we travel through this immense spiral city of light, let the unimaginable distances wash over you, not as something fearful, but as a comforting blanket of infinite space. There is no rush here, only the slow, majestic turning of the great galactic wheel, carrying us gently through cosmic time. If you enjoy these quiet explorations, I invite you to like, subscribe, or share a thought below. It helps other curious minds find a place to rest. But for now, get comfortable. Let your eyes grow heavy. Let's begin. The Milky Way is technically classified as a barred spiral galaxy, possessing a distinct central structure of stars. When we imagine a spiral galaxy, we often picture a perfect, uniform pinwheel, like water swirling gracefully down a vast cosmic drain, with arms that curve directly from a glowing spherical core. For a long time, astronomers believed our own galactic home followed this simple, elegant model, based on what they could see of distant cousins in the dark sky. However, detailed observations from our vantage point deep within the structure have revealed a more complex and majestic reality. The heart of the Milky Way is not a simple sphere, but a massive rectangular bar composed of ancient reddish stars, stretching across the center like a grand cosmic anchor. It is from the ends of this colossal glowing bar that the major spiral arms unfurl, wrapping around the galaxy in a sweeping, graceful embrace that contains billions of worlds. This central bar may be a temporary mature phase in our galaxy's long life, a sign of its settled, stately age, turning slowly in the void as a monument to the billions of years it has taken to reach this grand and intricate form. Our galaxy is so immense that even light, the fastest thing in existence, takes over 100,000 years to cross it. To understand the true scale of our home, we must try to imagine a journey that defies human comprehension, a voyage where speed itself becomes seemingly sluggish against the sheer vastness of the terrain. If you could ride a single photon of light, leaving our sun and traveling at unimaginable speeds that could circle the Earth 7 times in a single second, you would still need 100 millennia just to travel from one edge of the Milky Way starry disk to the other. The light we see tonight from the distant far side of the galaxy left its source when early humans were just beginning to walk the plains of Africa, taking its entire epoch-spanning journey just to reach your eye this very evening. This immense distance is not a barrier, but a comforting blanket of space, a vast and quiet buffer that gives every star system its own private corner of the dark. allowing countless worlds to evolve in the quiet safety of isolation. We do not reside in the busy center of the galaxy, but rather in a quiet, unassuming suburb known as the Orion Spur. It is easy to think that a star as important to us as our Sun would hold a privileged place near the majestic heart of the galaxy, perhaps amidst the dense, bright barred clusters of the core. Yet we find ourselves far from that crowded, energetic downtown, drifting peacefully about 26,000 light-years from the center. We reside in a smaller, partial structure called the Orion Spur, a gentle bridge of stars located comfortably between the massive, sweeping Perseus and Carina Sagittarius arms. This location is arguably perfect for life. We are far enough from the intense radiation and gravitational chaos of the dense galactic core, yet close enough to other stars to see their beauty painting our night sky. We are tucked away in a safe, quiet neighborhood of the Milky Way, a peaceful eddy in the great stellar river, allowing our solar system to mature undisturbed for billions of years. Our entire solar system is currently orbiting the center of the galaxy at a breathtaking speed of roughly 500,000 miles per hour. Even when you feel perfectly still, sitting quietly in your chair as the Earth sleeps around you, you are moving at speeds that would cross continents in mere seconds. Our planet, tethered securely to the Sun, is racing through the interstellar medium as we make our grand lap around the distant galactic heart. Yet the galaxy is so incomprehensibly vast that even at this tremendous speed, it takes approximately 225 to 225,000 years, 50 million Earth years to complete just one single orbit, a period known as a galactic year. The last time we were in this exact spot in our galactic journey, dinosaurs were just beginning to rise to dominance on the Earth, and flowers had not yet evolved to go on a bloom. We are travelers on a voyage so long that entire geological eras pass like mere moments, a gentle, endless carousel ride through the cosmos that has been turning since long before we were here, and will continue long after we are gone. The Milky Way contains roughly somewhere between 100 and 400 billion individual stars. The number is so large it becomes almost abstract, a figure that slips away from our ability to truly visualize it, melting instead into a general sense of awe. If you were to try and count every single star in our galaxy, counting one new star every single second, without ever stopping to eat, sleep, or rest, it would take you thousands of years just to finish the census. Each of these hundreds of billions of points of light is a sun, many likely tending to their own families of silent planets, their own quiet moons, and perhaps their own undiscovered oceans. When you look up at the clearest possible night sky from Earth, you are seeing only a tiny, almost insignificant fraction of this grand total, just the nearest neighbors in our immediate stellar vicinity. We are surrounded by a silent, glittering multitude, an ocean of potential worlds that fills the dark with an unimaginable wealth of light and possibility. At the very heart of our galaxy lies a supermassive black hole known as Sagittarius A, acting as the grand anchor of our spiral home. 4 million times more massive than our own Sun, this colossal object sits silently in the center of the Milky Way, shrouded by thick clouds of interstellar dust and gas that hide it from our direct view. While the term black hole might sound intimidating, in the grand scale of the galaxy, it is a stabilizing, majestic presence, a gravitational keystone around which the whole magnificent structure slowly pivots. It does not voraciously consume everything around it. Rather, nearby stars orbited peacefully and precisely, like comets orbiting our sun, tracing elegant, predictable paths over decades. It is the silent, sleeping giant at our core, its immense gravity helping to govern the central regions, a dark and quiet heart that has beaten steadily for billions of years, holding the center firm while we drift safely in the distant outer arms. The Milky Way is nearly as old as the universe itself, having formed roughly 13.6 billion years ago. Our galaxy is not a recent addition to the cosmos, but an ancient, foundational structure that has witnessed almost the entire history of time. Just a few 100 million years after the vast, silent expansion of the Big Bang, the first wisps of hydrogen and helium began to pool together in the primordial dark, drawn by gravity into the seeds that would become the Milky Way. It has spent over 13 billion years gathering itself, growing from a small, irregular cluster of ancient gas into the grand, majestic spiral we inhabit today. Every star we see, every nebula, and every planet is part of this incredibly long heritage, a continuous, unbroken story of stellar birth and evolution that stretches back to the very dawn of everything. We are living in an ancient, grand old house, one that has stood firm while the universe around it grew, expanded, and matured into the vast expanse we see tonight. Our galaxy has grown to its current majestic size by gently absorbing smaller, older galaxies over eons. Throughout its incredibly long life, the Milky Way has engaged in a slow, graceful dance with smaller neighboring satellite galaxies that drifted too close to its immense gravitational pull. Rather than violent collisions, these events are more like grand mergers, where the smaller galaxy is slowly, over billions of years, drawn into the larger structure, its stars spreading out to become new streams and ribbons within our own halo. It is a form of cosmic recycling, where nothing is truly lost, but rather incorporated into a greater whole, adding new stars and new ancient history to our own. Even now, astronomers can see the faint, ghostly trails of these past mergers wrapping around us. Silent reminders of ancient systems that have now found a new home within the comforting bulk of our own massive galaxy. Surrounding the main flat disk of our galaxy is a vast, spherical halo containing the oldest stars, known as globular clusters. While most of the bright stars, gas, and active nebulae reside in the flat, pancake-like disk where we live, the galaxy is actually embedded in a much larger, almost invisible sphere. This halo is like a grand, ancient attic, storing the relics of our galaxy's earliest days in the form of globular clusters, tightly packed balls of hundreds of thousands of ancient stars that have held together for billions of years. These clusters orbit efficiently high above and far below the galactic plane, like silent sentinels watching over the younger, busier disks below. They are peaceful, incredibly stable communities of stars that have long since finished their primary evolution, glowing with a steady, reddish light that speaks of immense age and undying patience as they circle the galaxy forever. The visible Milky Way is surrounded by a profoundly massive, invisible cloud known simply as the dark matter halo. What we can see with our eyes and our telescopes, the billions of glittering stars, the glowing clouds of gas, the sweeping spiral arms, makes up only a tiny fraction of the galaxy's true total mass. The vast majority of our galactic home is composed of a mysterious, invisible substance that does not glow, reflect, or absorb light. Yet its presence is felt through the gentle but firm grip of its gravity. This dark matter forms a gigantic, unseen scaffolding that extends far beyond the visible edge of the stars, holding the spinning galaxy together so it doesn't fly apart as it rotates. We are essentially floating in a vast, invisible ocean of this unknown material, a silent, protective cocoon that provides the unseen structure necessary for our beautiful, visible home of light to exist at all. The disk of the Milky Way is not perfectly flat, but is actually warped, like a vinyl record that has been left in the sun. We often see illustrations of galaxies as perfectly flat disks, but the reality of our home is more organic and dynamic. The immense disk of stars and gas, stretching 100,000 light-years across, has a gentle, graceful bend to it, curling upwards on one side and downwards on the other. This warp is likely caused by the subtle, long-term gravitational influence of our satellite galaxies, like the large and small Magellanic Clouds, which gently tug at the Milky Way's edges as they slowly orbit us. It is a reminder that the galaxy is not a rigid, frozen sculpture, but a flexible, responsive body that reacts to the gentle gravitational currents of its environment, bending softly like a leaf floating on a quiet pond, forever adjusting its shape in a slow cosmic dance. Our entire galaxy, along with dozens of its neighbors, is being pulled towards a mysterious region known as the Great Attractor. While we orbit the Sun, and the Sun orbits the galactic center, the entire Milky Way itself is on a grander voyage still, drifting through the intergalactic void towards a massive gravitational anomaly millions of light years away. We cannot see exactly what this great attractor is, as it lies hidden behind the dense dust clouds of our own galactic plane, blocked from our view like a hidden valley behind a mountain range. But we can feel its gentle tug, a cosmic current that is slowly drawing our entire region of the universe towards it over billions of years. It is a flow so vast and slow that it poses no danger, just another layer of grand, majestic motion in a universe where nothing ever truly stands still, carrying us gently towards an unknown, distant rendezvous. In roughly 4.5 billion years, the Milky Way is destined to merge with our massive neighbor, the Andromeda galaxy. Currently, Andromeda is just a faint smudge of light in our night sky, but it is slowly, inevitably drifting towards us across the cosmic void. This future meeting will not be a sudden, catastrophic crash, but a painfully slow, majestic intermingling that will take millions of years to unfold. Because the spaces between stars are so incredibly vast, it is very unlikely that any two individual stars will actually collide during this event. Instead, the two galaxies will pass through one another like ghosts, their gravity slowly reshaping them into a single, grander elliptical galaxy. It will be a beautiful, silent transformation, a marriage of two massive islands of light, creating a new, larger home for all the stars within them, long after our own sun has finished its days. The Milky Way's disk is actually separated into two distinct components, the thin disk and the thick disk. The region we inhabit, the thin disk, contains most of the galaxy's gas, dust, and young, bright stars, all bobbing up and down slightly as they orbit the center in a relatively tight plane. But surrounding this is a thick disk, a more diffuse, puffed-up region that contains far older stars. These ancient travelers in the thick disk do not adhere strictly to the flat plane. They follow more chaotic, swooping paths that take them high above and far below the younger stars of the thin disk. It is like a bustling modern city built directly on top of far older, quieter ruins, with the two populations of stars mingling gently at the boundaries, representing different eras of our galaxy's long and complex history of construction. Our galaxy is a remarkably fertile place, constantly giving birth to new stars in vast, glowing clouds called nebulae. Deep within the spiral arms, nestled in the cold dark, are immense clouds of hydrogen gas and dust that act as stellar nurseries. In these quiet, mostly hidden regions, gravity gently pulls clumps of dust together until they become dense and hot enough to ignite, sparking the first light of a brand new sun. These nurseries, like the famous Orion Nebula, are places of profound, slow-motion creation, where thousands of potential solar systems are currently forming, wrapped in protective cocoons of glowing gas. It is a continuous cycle of rebirth that has kept our galaxy shining for billions of years, ensuring that as old stars fade quietly into the dark, new light is always being kindled to take their place in the grand tapestry. The space between the stars in our galaxy is not truly empty, but filled with a thin soup known as the interstellar medium. While it might look like total pitch-black emptiness between the pinpricks of starlight, the galaxy is actually permeated by a very tenuous ocean of gas and microscopic dust particles. This medium is incredibly thin, far emptier than the best vacuum we could ever create in a laboratory on Earth. Yet over the vast distances of light years, it adds up to immense clouds that can drift and swirl like smoke. It is the raw material of the galaxy, the stuff from which new stars are made and to which old stars return their material when they die. We are sailing through this almost invisible mist right now, our solar system parting the thin sea of interstellar atoms as we make our endless journey around the galactic core. Rising above and below the galactic center are two colossal structures known as the Fermi bubbles. These are two gigantic, balloon-like structures of incredibly hot gas and energetic particles that tower tens of thousands of light years above and below the flat disk of the Milky Way. Invisible to our human eyes, they were only discovered recently by telescopes that can see in gamma rays, revealing a hidden, majestic component of our galaxy's anatomy. They may be the echoes of a past outburst from the supermassive black hole at our core, ancient burps of energy that have slowly inflated these colossal bubbles over millions of years. They stand now like silent, invisible monuments to the galaxy's more active past, towering quietly over the spiral arms where we live our lives. Just like a solar system has a habitable zone where liquid water can exist, the galaxy itself has a galactic habitable zone. Astronomers believe there is a sweet spot within the Milky Way, a ring-shaped region not too close to the dangerous radiation-filled core, but also not too far out in the desolate, metal-poor rim. We are lucky enough to reside within this favorable zone, where conditions are settled and calm enough for complex systems to develop over billions of years without being constantly sterilized by nearby supernovae or intense bursts of radiation. It is a vast, safe harbor within the greater, more chaotic ocean of the galaxy, a fortunate band of tranquil space that may well harbor other quiet, watching worlds enjoying the same safety that we do. The oldest known star within our galaxy, affectionately nicknamed the Methuselah star, is on the order of 13 to 14 billion years old. This ancient star, officially known as HD 140283, is a fascinating cosmic paradox because for a long time it even seemed slightly older than the currently accepted age of the universe itself. a puzzle that astronomers have been gently unraveling with better measurements and improved models. Regardless of its exact age, it is a true relic, a star that has been burning since almost the very first moments of existence, long before our galaxy had even fully formed into a spiral. It has traveled quietly through the dark for practically all of time, a silent, enduring witness to the entire history of the cosmos, still shining peacefully in our night sky, just a few hundred light years away from us. Every picture you have ever seen of the Milky Way as a complete spiral is actually an artist's illustration or a photo of another galaxy. Because we are embedded deep inside the disk, about halfway out from the center, we cannot possibly step outside our galaxy to take a selfie of the whole structure. It would take millions of years for even our fastest spacecraft just to get high enough above the galactic plane to see the spiral shape we know exists. Instead, we have painstakingly mapped our home from the inside out, measuring the distance and speed of millions of stars to build a mental model of the grand structure we inhabit. We are like keen-eyed sailors on a vast ocean who have deduced the shape of their entire world without ever having seen it from the shore, relying on patience, mathematics, and starlight to reveal the grandeur of our own home. We do not just orbit the center of the galaxy in a flat circle, but also gently bob up and down like a cork on gentle ocean swells. As our solar system makes its grand 250 million year journey around the Milky Way, it does not travel in a perfectly straight, unwavering line. Instead, influenced by the complex gravitational pull of the varied mass within the galactic disk, we slowly oscillate, drifting above the main plane of the galaxy, and then dipping back down below it in a rhythmic cycle. This grand vertical wave takes roughly 60 million years to complete just one single oscillation, a time frame so vast that entire species rise and fall on Earth during a single bob. It means our journey through the cosmos is truly a three-dimensional voyage, a slow, hypnotic waltz that carries us through different layers of the galactic medium. We are currently near the central plane, having passed through it gently a few million years ago, continuing our slow, rocking motion as we sail onward through the endless dark. If you could look at the Milky Way from the outside, it would appear yellowish-white, like old parchment or warm cream. While photographs often show galaxies bursting with vibrant blues, pinks, and purples, these are usually false color images designed to highlight specific, invisible gases or energetic regions for scientific study. To the human eye, the true combined light of hundreds of billions of stars would blend into a soft, warm, milky glow, dominated by the countless older, cooler stars that make up the bulk of the galaxy's mass. The younger, brighter blue stars, while intense, are far fewer in number, merely peppering the spiral arms like glittering jewels on a mostly golden crown. It is a comforting, mature color, the color of a galaxy that has settled into a long, steady middle age, burning quietly and consistently in the vast coolness of intergalactic space. Most of the stars in our galaxy are not solitary wanderers like our Sun, but are born in pairs or triplets, locked in eternal gravitational dances. When we look up at a single point of light in the night sky, more often than not, we are actually seeing two or more stars orbiting one another so closely that our eyes blend them into one. These binary or multiple star systems are the norm in the Milky Way, where stars spend their billions of years of life circling a companion in a perfectly balanced, silent waltz. They might be similar suns or vastly different partners, such as a massive red giant gently sharing its outer layers with a tiny white dwarf, but they remain tethered together by the unbreakable bonds of gravity. It is a comforting thought that loneliness is rare among the stars. They almost always have a partner to share the long, dark journey through the galactic epochs. Our galaxy is surrounded by vast, invisible rivers of stars known as stellar streams. These are the ghostly remnants of ancient dwarf galaxies or old star clusters that were long ago captured by the Milky Way's immense gravity and slowly pulled apart. Over billions of years, they have been stretched out into long, thin ribbons of stars that wrap around our galaxy, still traveling together on similar paths, like a cohesive school of fish in a vast ocean. They are the silent archaeological ruins of the cosmos, telling the story of how our galaxy grew by gently absorbing its smaller neighbors over deep time. We are likely drifting through several of these invisible streams right now, surrounded by stars that were born far away in different cosmic clans, now adopted peacefully into our own massive galactic family. There is a massive, dark band seemingly splitting the Milky Way in our night sky, known to astronomers as the Great Rift. When you see the beautiful Milky Band of our galaxy stretching overhead on a clear night, you might notice strange, dark patches where no stars seem to shine, as if holes had been punched in the heavens. These are not actually empty spaces, but rather immense, thick clouds of interstellar dust hanging in the foreground, silhouetted against the bright background of billions of distant stars. Like grand cosmic curtains, they block the light from the bustling galactic center, creating mysterious shapes that many ancient cultures saw not as absences of light, but as dark constellations in their own right, such as a great emu or a celestial river serpent. These quiet, cold clouds are simply resting there, drifting peacefully, waiting for the distant future when they might collapse to form new stars of their own. We live inside a vast cavity of thin, hot gas, roughly 1,000 light-years across, known as the local bubble. Our region of the Milky Way is unusually empty of dense gas and dust clouds, like a clear meadow in the middle of a thick forest. Astronomers believe this bubble was carved out millions of years ago by ancient supernovae, stars that ended their lives in brilliant flashes of energy, gently pushing the surrounding interstellar medium away to create this quiet, cleared-out cavern. We have been drifting through this calm, low-density region for millions of years, enjoying a remarkably clear view of the distant universe that might otherwise be obscured by thicker local fogs. It is a safe, quiet harbor that was prepared for us long before humanity existed, a peaceful clearing in the grand galactic woods. The outer edge of the Milky Way is not a sharp cliff, but a gentle fading away into the intergalactic void. There is no specific signpost where our galaxy officially ends and the rest of the universe begins. Instead, the stars just gradually become sparser and sparser the further out you go. This outer rim is a lonely, quiet place where the distance between stars becomes immense and the grand spiral structure fades into a scattered haze of distant, solitary sentinels. These far-flung stars are the deepest travelers of our system, orbiting so slowly in the profound dark that they have barely moved since they were born. They mark the gentle transition from the comforting gravity of home to the endless open ocean of deep intergalactic space, guarding the quiet borders of our island universe. Our galaxy has a magnetic field that twists and turns through the spiral arms like invisible giant ribbons. Just as the Earth has a magnetic field that guides compass needles, The entire Milky Way possesses a vast, complex magnetic structure that spans tens of thousands of light years. It is incredibly subtle, roughly 100,000 times weaker than Earth's field, yet over these immense distances, it is strong enough to gently guide the motion of charged gas clouds and cosmic rays. These invisible field lines thread through the interstellar medium, acting like a grand, silent skeleton that helps shape the majestic spiral arms and supports giant clouds of gas against their own gravity. It is a hidden, protective influence, quietly organizing the chaos of the galaxy into the beautiful, orderly shapes we see today. Between the stars drift countless rogue planets, worlds that have no sun to call their own. Not every planet is tethered to a star. Billions of worlds in our galaxy are free floaters, drifting alone through the eternal night of interstellar space. These are not sad or violent places, but peaceful, silent travelers, forever sailing the calm, endless dark between the stellar islands. They might have been gently nudged away from their parent stars eons ago, now embarking on grand solitary voyages that will last for billions of years. Unburdened by seasons or years, they exist in a state of perpetual frozen stillness, quiet wanderers that add unseen mass and mystery to the vast, empty spaces of our galactic home. The central bulge of the Milky Way is remarkably rich in old red stars, giving it a warm, glowing ancient heart, while the spiral arms where we live are blue and bright, with energetic youth and new star formation. The downtown core of the galaxy is a totally different environment. It is a densely packed metropolis of ancient stars that formed when the galaxy was just beginning, glowing with a steady, cool red light that has persisted for billions of years. There is very little gas left in this central region to form new stars. Instead, it is a settled, mature retirement community for the galaxy's oldest residents. They orbit the core in chaotic, swarm-like paths, a vast, glowing sphere of cosmic history that anchors the rest of the spinning disk. Every year, only a handful of new stars are born somewhere within the vast expanse of our galaxy, on the order of a few to perhaps 7. It is a quiet, continuous process of creation that never truly stops, happening deep inside the opaque, dark clouds of gas scattered through the spiral arms. While only a handful of stars a year might sound low for such a huge place, it adds up over the immense lifespan of the galaxy to billions of new suns, each potentially bringing new planets and new stories into existence. It means that even as you rest right now, somewhere far across the galactic disk, a new point of light is flicking on for the very first time, beginning its own multi-billion-year journey through time. The galaxy is not a static painting, but a living, breathing garden that is forever blooming with new light, even in its quietest corners. The spiral arms of the Milky Way are actually density waves, more like traffic jams than permanent structures. We often think of the spiral arms as rigid objects, like the spokes of a wheel, but they are actually moving patterns that stars drift into and out of over time. Just as cars on a highway might bunch up in a slow-moving area and then speed up again when they pass it, stars and gas clouds slow down slightly as they enter these denser spiral regions. This gentle crowding is what compresses the gas clouds to form new stars, lighting up the arms like strings of pearls before they eventually drift out the other side. We are currently passing through such an arm, enjoying the bright local neighborhood before we eventually sail back into the quieter, darker spaces between the arms. There are stars in our galaxy that are moving so fast they will eventually escape the Milky Way entirely. Known as hypervelocity stars, these rare travelers are moving at millions of miles per hour, far exceeding the gravitational speed limit of the galaxy. They were likely given a tremendous gravitational kick by a close encounter with the supermassive black hole at the center, slung outward like stones from a cosmic slingshot. They are destined to leave our galactic island forever, sailing out into the immense, lonely void between the galaxies, never to return. They are the ultimate explorers, leaving the safety of home to drift forever in the truly endless, uncharted ocean of the wider universe. Our galaxy is constantly being bombarded by high-energy particles from deep space known as cosmic rays. These are tiny atomic fragments, traveling at nearly the speed of light, raining down on the galactic disk from all directions like a gentle, invisible drizzle. They come from distant supernovae, active black holes in other galaxies, and ancient events from the dawn of time, carrying tiny messages from across the universe. Our planet's atmosphere and magnetic field safely absorb most of them, turning them into harmless flashes of light high in the upper air, sometimes contributing to the beautiful auroras. We are constantly bathed in this gentle rain of ancient stardust, a subtle, unending connection to the most distant and energetic reaches of the cosmos. The Milky Way is just one of more than 50 galaxies that make up our immediate cosmic neighborhood, known as the local group. We do not drift alone in the void. We are part of a small, intimate village of galaxies held together by mutual gravity. Our Milky Way and the Andromeda galaxy are the two big siblings of this family, surrounded by dozens of smaller dwarf galaxies that orbit us like devoted moons. This entire group is drifting together through the expanding universe, a quiet, cohesive clan of stellar islands that will stay together even as the rest of the universe speeds away from us. It is a comforting thought that on the largest scales, our home is part of a stable, enduring community that will remain close-knit until the end of time. Vast curtains of cold dust hide huge sections of our own galaxy from our view, a region known as the zone of avoidance. Because we live right inside the flat, dusty disk of the Milky Way, looking towards the center is like trying to see a distant city through a thick bank of fog. This dust blocks almost all visible light, creating a mysterious zone in the sky where we cannot see distant galaxies that lie behind our own. It was a long-standing mystery until modern infrared telescopes allowed us to peer through the veil, revealing a whole universe of galaxies that had been hiding quietly behind our own backyard for all of human history. It reminds us that what we cannot see is often just as vast and wondrous as what we can, patiently waiting for us to find the right way to look. The Milky Way's halo is filled with invisible, dark subhalos, small clumps of dark matter that have no stars at all. Theories suggest that thousands of small, pure dark matter clumps might be swarming around our galaxy right now, completely invisible because they never managed to attract enough gas to form stars. They are like ghost galaxies, possessing mass and gravity but no light, drifting silently through our own visible galaxy without us ever noticing. They might pass right through our solar system without causing so much as a ripple, silent, intangible voyagers that outnumber the visible satellite galaxies by hundreds to one. It is a humbling realization that the bright, starry galaxy we see might just be the visible tip of a much larger, darker, and quieter iceberg. Just outside the main spiral disk, there exists a mysterious ring-like structure of stars known as the Monoceros Ring. This is a vast ribbon-like circle of stars that wraps around the Milky Way, roughly 60,000 light-years from the center, containing hundreds of millions of suns. Astronomers are still patiently debating its origin. It might be a ripple in the galactic disk itself, or more likely, the incredibly stretched-out remains of an ancient dwarf galaxy that was long ago wrapped around us like a cosmic scarf. Whatever it is, it sits quietly on the outskirts of our home, another beautiful, ghostly layer to the complex and ancient anatomy of the galaxy we call home. Our galaxy is filled with complex organic molecules, the basic chemical building blocks of life. In the vast, cold clouds between the stars, atoms do not just sit idly. They slowly bond together over millions of years to form surprisingly complex chains of carbon, hydrogen, and oxygen. We have detected vast clouds containing alcohols, sugars, and even simple amino acids drifting freely in deep space, long before any planets have formed near them. It seems the universe is naturally primed for complexity, creating the seeds of life in the deepest, coldest dark, waiting for them to be swept up into new solar systems where they might one day find a warm ocean to thrive in. The potential for life is woven into the very fabric of the Milky Way itself. We are currently living in what might be considered the Milky Way's golden afternoon. Our galaxy is past its tumultuous, fiery youth, when quasars blazed and rapid collisions were common. But it is still far from the dim, fading twilight of its eventual old age. We exist in a long, stable, fertile period, where generations of stars have enriched the cosmos with heavy elements, allowing complex planets like Earth to form. Yet there is still plenty of fuel left for billions of years of new star birth. It is a calm, majestic era in the galaxy's life, a perfect, protracted moment of balance and beauty that provides a safe, steady cradle for us to wake up in and look around at the wonders of the dark. Directly adjacent to our galaxy lies a bewilderingly vast region of almost nothingness known as the local void. While gravity pulls galaxies together into clusters and sheets, it also empties out vast regions of space between them, creating colossal cosmic deserts. The local void is one such majestic emptiness, starting right at the edge of our own local group and stretching for nearly 150 million light-years into the deep dark. It is not truly empty, but it is astoundingly desolate, containing only a handful of lonely, isolated dwarf galaxies lost in an ocean of pristine nothingness. Interestingly, this void is not just passive empty space. Because it has less gravity than the crowded regions, it effectively acts like a repulsive force, gently pushing our Milky Way and its neighbors away from it. We are slowly surfing away from this immense region of cosmic silence, carried by the gravitational currents of richer, denser regions of the universe. Our galaxy is currently sailing through a wispy cloud of interstellar gas affectionately known as the local fluff. Even the empty space between stars has texture and varying density, like patches of fog on a clear night road. For the last few tens of thousands of years, encompassing all of recorded human history, our entire solar system has been passing through this specific, slightly denser region of warm hydrogen and helium, roughly 30 light-years across. It is incredibly tenuous. If you could scoop up a coffee cup full of this cloud, it might contain only a single atom, yet over vast distances, it is enough to be measurable by our sensitive instruments. We will likely drift out of this gentle cosmic fog bank in another 10 or 20,000 years, entering a new, clearer region of the interstellar medium as we continue our endless voyage around the galactic center. Billions of years from now, the Milky Way will eventually quiet down as its supply of gas for new stars is finally exhausted. Galaxies have life cycles much like living things, and our Milky Way is currently in its vibrant, productive middle age. But eventually, after unimaginable eons have passed, the abundant clouds of cold hydrogen gas that act as fuel for new star birth will be used up, locked away inside dead stars, or blown out into intergalactic space. When that incredibly distant day comes, the brilliant blue lights of new stars will no longer switch on, and the galaxy will slowly settle into a redder, quieter, and more serene state. It will become a majestic gallery of older, steadily burning suns, a peaceful, retired galaxy that has finished its work of creation and is content to simply drift through the rest of eternity. A significant portion of the stars currently in our galaxy were not born here, but are immigrants from other, smaller galaxies. As the Milky Way has gently absorbed dwarf galaxies over its long lifetime, it has welcomed their stars into its own vast population. Astronomers can identify these alien stars by looking at their strange orbits or their unique chemical compositions, which differ subtly from native-born Milky Way stars. They might be traveling in the opposite direction to the rest of the galactic traffic, or dipping steeply through the disk, carrying the silent memories of their long-lost home galaxies. They are perfectly integrated now, adopted children of the Milky Way that have found a permanent, safe home within our massive spiral arms after their own original galaxies faded into history. If you could stand on a planet near the center of the galaxy, the night sky would be a blindingly brilliant tapestry of light. Here, in the quiet suburbs of the Orion Spur, we see a few thousand stars with our naked eyes on the clearest of nights. But in the dense, crowded downtown of the galactic core, stars are packed together hundreds or even thousands of times more tightly than in our neighborhood. A night sky there would not be dark. It would be ablaze with perhaps 1 million stars brighter than Sirius, casting distinct shadows and bright enough to read by comfortably at midnight. It would be a sky of perpetual, overwhelming majesty, where the sheer density of neighboring suns would make you feel constantly swaddled in a warm blanket of eternal starlight, never truly knowing a totally dark night. The Milky Way is exhaling grand, high-speed winds of hot gas from its center out into deep space, driven by the intense activity of star birth and the energetic stirrings of the central supermassive black hole. Fantastic fountains of hot particles are constantly streaming outward from the galactic core. These galactic winds do not rush violently, but flow in a steady, majestic stream over millions of years, carrying heavy elements manufactured in the hearts of stars out into the vast halo surrounding us. It is like a grand slow-motion circulatory system, enriching the enormous empty spaces around the galaxy with the chemical seeds of future potential. This gentle exhalation helps regulate the galaxy's temperature and growth, a long, slow breath that has been cycling for eons. The vast majority of stars in our galaxy are tiny, dim, red dwarfs that will outlive our own sun by trillions of years. While the bright blue and yellow stars catch our attention, they are rare celebrities compared to the silent, overwhelming majority of the galactic population. Red dwarfs are small, cool stars, often with less than half the mass of our sun, burning their nuclear fuel so slowly and efficiently that they are practically eternal compared to human timescales. They are too dim to be seen with the naked eye from Earth. Not even the closest one, Proxima Centauri, is visible to us without a telescope. Yet they are everywhere, quietly glowing in the dark. Long after our sun has faded, these small, patient stars will still be shining steadily, keeping the galaxy warm and lit for an almost incomprehensibly long future. Radio telescopes have revealed that our galaxy emits a constant, gentle hiss of radio waves. In the early days of radio, pioneers were puzzled by a persistent static that seemed to come from everywhere in the sky, peaking when their antennas pointed toward the Milky Way's center. We now know this is the voice of the galaxy itself. Synchrotron radiation generated by energetic electron spiraling through magnetic fields and the hum of ancient hydrogen clouds. It is a cosmic white noise that has been broadcasting since long before humanity existed, a soothing, unending background song that fills the silence of space. It is a reminder that even in the apparent quiet of the night, the galaxy is alive with energy, constantly whispering its presence to anyone with the ears to listen. There is a massive, invisible structure of dark matter called the dark matter skeleton that dictates where galaxies like ours can form. On the grandest scales, the universe is not random, but structured like a vast, three-dimensional cosmic web made of dark matter filaments. Our Milky Way, along with our local cluster, sits at the intersection of some of these grand, invisible threads, like a glittering dewdrop caught on a spider's web. Gravity drew regular matter, the gas and dust we can see, onto this pre-existing invisible scaffolding billions of years ago, to form the galaxies we see today. We are resting securely within one of the dense nodes of this grand cosmic architecture, held in place by vast, unseen supports that stretch across the entire visible universe. Some of the Milky Way's oldest stars are gathered in the stellar halo, a vast diffuse sphere that extends far beyond the visible disk. While the grand spiral arms are flat like a plate, they are embedded in a tenuous, ghostly ball of ancient stars that move on lonely, plunging orbits. These stars are the hermits of the galaxy, spending most of their time far out in the lonely, empty regions above and below the busy galactic plane. They only dive through the crowded disk briefly before soaring back out into the quiet dark for millions of years. They are the pristine, metal-poor survivors of the galaxy's very first era of star formation, patrolling the distant frontiers of our home like silent, ancient guardians. Hundreds of millions of years ago, the Milky Way may have collided gently with a smaller galaxy, sending ripples through our disk that we still feel today. Just as throwing a pebble into a quiet pond creates ripples that spread outward long after the stone has sunk, a past interaction with a dwarf galaxy likely caused the subtle ringing we currently detect in the Milky Way stars. Astronomers have found large groups of stars moving up and down in synchronized waves, a lingering echo of that ancient soft collision. It was not a destructive event, but a gentle nudge that set the grand disk slowly oscillating, a cosmic memory preserved in the harmonious motions of billions of stars, eons after the event itself has been forgotten. Deep in interstellar space, the density of matter is so low, it is practically a perfect vacuum. When we talk about clouds in space, we must adjust our sense of scale. These are not like the thick, fluffy water clouds of Earth. A typical cloud of interstellar gas in the Milky Way is unbelievably tenuous, far thinner than the best vacuum human technology can create in a laboratory. If you were to wave a butterfly net through this space, you might only catch a few individual atoms in each sweep. Yet, because the space between stars is so incomprehensibly vast, these almost nothings add up to gigantic, massive structures that can birth whole solar systems. It is a realm of profound, undisturbed stillness, where atoms can travel for years without ever bumping into one another. Our galaxy is surrounded by two major satellite companions, visible to the naked eye in the southern hemisphere, the Magellanic Clouds. These are two irregular dwarf galaxies that have been captured by the Milky Way's gravity and are now our constant, loyal companions. They look like detached pieces of the Milky Way, glowing softly in the southern night, and they are slowly orbiting us in a grand billion-year waltz. They are connected to us by a long stream of gas called the Magellanic Stream, a bridge of material pulled out by our gravity as they pass by. They are beautiful reminders that our galaxy is the gravitational anchor for a whole diverse family of smaller structures, guiding them safely through the intergalactic night. Every star we can see with the naked eye is contained within a relatively tiny bubble close to our Sun. When you look up at a star-filled sky on a perfect moonless night, it feels like you are seeing the whole universe, but you are really only seeing our immediate local neighborhood. Almost every individual star you can see without a telescope is within a few thousand light years of Earth, a mere stone's throw in a galaxy that is 100,000 light years across. The vast majority of the Milky Way lies far beyond our unaided vision, hidden by distance and dust. We are like people living in a cozy valley, able to see the nearby houses clearly, but only dimly aware of the immense, sprawling continent that lies beyond the surrounding hills. The center of our galaxy is smelling distinctly of rum and tasting faintly of raspberries. It sounds like pure poetic whimsy, but radio astronomers analyzing the vast dust cloud, Sagittarius B2, near the galactic center, found it contains enormous amounts of a molecule called ethyl formate. On Earth, this specific chemical is partially responsible for the flavor of raspberries and carries the distinct aroma of rum. While you couldn't actually breathe it in, the cloud is lethally thin and cold. It is delightful to know that deep in the grand, imposing heart of our galaxy, complex chemistry has created vast, ghostly clouds that carry the faint, unexpected essences of familiar earthly comforts. The Sun is currently traveling through a local region of bright, young stars known as the Gould Belt. This is a ring of relatively young stars, only about 500 million years old, that seems to be tilted relative to the main galactic disk. It includes many of the brightest and most famous constellations we see, like Orion, Scorpius, and Crux. We are just passing through this beautiful neighborhood, enjoying the spectacular views of these brilliant local stars before we drift on. It is thought this ring might be the slowly expanding remnant of an ancient, giant gas cloud that formed stars long ago, a stellar nursery that we are now lucky enough to be sailing through in our long journey. Some dead stars in our galaxy have cooled down enough to become gigantic, crystallized diamonds. When a star like our Sun reaches the end of its long life, it gently puffs away its outer layers and leaves behind a dense, hot core called a white dwarf. Over billions of years, these remnants slowly cool and their carbon interiors can crystallize under the immense pressure. Astronomers have discovered such stars, like Lucy, in the constellation Centaurus, which is essentially a diamond 10 billion trillion carats in size, resting quietly in the deep dark. They are the ultimate hidden treasures of the Milky Way, silent, glittering monuments to stars that once warmed their own vanished worlds. We can use the varying compositions of stars to perform galactic archaeology and trace the Milky Way's ancestral history. Just as archaeologists on Earth dig through layers of soil to understand the past, astronomers look at the chemical makeup of different stars to understand the galaxy's history. The oldest stars are made almost entirely of hydrogen and helium, while younger stars like our Sun are rich in heavier elements forged by previous generations. By mapping these different populations, we can reconstruct how the galaxy was built up slowly, layer by layer, merger by merger, over 13 billion years. The entire history of our home is written in the light of the stars, waiting patiently for us to learn how to read it. A massive cloud of hydrogen gas, known as the Smith Cloud, is currently on a collision course with the Milky Way. This immense cloud, millions of times the mass of our Sun, was likely launched out of the galaxy eons ago and is now falling back in like a returning boomerang. It is expected to crash gently back into the galactic disk in about 30 million years. When it arrives, it will not be a disaster, but a beautiful event of renewal. The impact will compress the gas and trigger a spectacular burst of new star formation. It represents a brilliant future fireworks display in slow motion, a delivery of fresh fuel that will light up a whole new region of the galaxy long after we are gone. If you are floating in intergalactic space outside the Milky Way, you wouldn't be able to see our Sun at all. Despite being remarkably bright to us, our Sun is a very average, undistinguished star in the grand scheme of the galaxy. From the distance of our nearest neighbor, Andromeda, 2.5 million light-years away, our magnificent Sun would be completely invisible to standard telescopes, lost entirely in the general, hazy glow of the billions of other stars in the Milky Way's disk. It is a humbling reminder that while our home star is everything to us, to the rest of the universe, it is just one tiny, anonymous grain of sand on an unimaginably vast and glowing beach. Hidden within the central regions of the galaxy is a vast, mysterious cloud of antimatter that is constantly annihilating. When we think of antimatter, it often sounds like something from science fiction, a volatile and dangerous substance that explodes upon contact with normal world. In the deep, dense heart of the Milky Way, however, it exists as a natural, ongoing phenomenon, creating a faint, steady glow of gamma rays that astronomers can detect from Earth. It is believed to be created by exotic, high-energy events near extreme stars or black holes, which then drift outward and quietly recombine with normal matter in a steady, silent dissolution of pure energy. It is not a violent war zone, but rather a continuous, natural cycling of exotic particles, a subtle, high-energy whisper that has been emanating from the galactic core for as long as we have been able to listen. Our solar system is gently nudged by the galactic tide, a gravitational force that can send comets heading towards Earth. Just as the moon raises tides in Earth's oceans, the immense sprawling mass of the Milky Way exerts a tidal force on the outer reaches of our own solar system. This gentle, large-scale gravitational tug is strong enough to slowly disturb the icy bodies resting in the distant Oort cloud, thousands of times further from the Sun than Pluto. Over millions of years, these gentle galactic nudges can dislodge these frozen travelers from their stable resting places, sending them on long, lonely inward journeys toward the Sun as magnificent long-period comets. It is a beautiful reminder that even the smallest, most distant pieces of our local neighborhood are dancing to the grand, slow rhythm of the galaxy as a whole. There is a special zone in the galaxy called the corrotation circle, where stars and spiral arms move at exactly the same speed. For most of the galaxy, stars are either overtaking the slow-moving spiral arms or being overtaken by them, constantly passing in and out of these denser traffic jams. But at a certain specific distance from the center, known as the corrotation radius, the stars are perfectly synchronized with the turning of the spiral pattern itself. A star system located in this unique tranquil zone would not experience the periodic compression and hustle of entering an arm, but would instead ride along peacefully within the arm for immense periods of time. It is like finding the perfect wave in the cosmic ocean and riding it indefinitely, a rare stable harbor in the dynamic swirling of the galactic disk. The most massive globular cluster in our galaxy, Omega Centauri, may actually be the stripped-down core of a long-lost dwarf galaxy. Omega Centauri is unique among the dense star clusters that orbit our galaxy. It is far larger, heavier, and more complex than any of its siblings, containing millions of stars with vastly different ages and varied chemical compositions. Astronomers now believe it is not a true cluster at all, but the ancient, dense heart of a small galaxy that was captured and slowly consumed by the Milky Way billions of years ago. Its outer layers of stars were peeled away by our galaxy's majestic gravity, leaving only this incredibly dense, brightly glowing central nucleus to orbit us forever as a silent, glittering memorial to a galaxy that once was. When stars like our Sun reach the very end of their lives, they create some of the most beautiful objects in the galaxy, known as planetary nebulae. Despite the confusing name, these have nothing to do with planets. They are the final glowing breaths of dying stars that gently puff their outer layers into deep space. These layers of glowing gas form intricate jewel-like shapes, rings, hourglasses, and butterfly wings that spread slowly outward, lit up in brilliant colors by the fading embers of the central white dwarf star. They are fleeting masterpieces in cosmic time, lasting only a few tens of thousands of years before dissipating forever into the general interstellar medium. They are the peaceful, artistic finales to billions of years of steady stellar burning, scattering the seeds of future creation back into the galactic void. The Milky Way is home to a mysterious, highly energetic object near the center dubbed the Great Annihilator. This dramatically named object is actually a quiescent black hole, quietly orbiting another star, but it occasionally produces spectacular focused jets of high-energy particles. It earned its imposing title because it is one of the brightest sources of gamma radiation related to antimatter annihilation in the entire galaxy. Yet, despite the fierce name, it sits thousands of light years away, a harmless curiosity that acts as a natural high-energy physics laboratory for astronomers. It is just another of the galaxy's many exotic residents, living its long, strange life in the crowded, energetic downtown of the Milky Way, far from our quiet suburban home. Stars are not always randomly scattered. Many are born together in loose, drifting families known as stellar associations. Unlike tightly bound clusters that stay together for billions of years, stellar associations are like groups of siblings that slowly drift apart as they mature. These are large, sparse groups of young stars that were all born from the same massive nursery cloud at roughly the same time, and still share a common motion through space. Over a few 100 million years, the gentle gravitational nudges of the rest of the galaxy will cause them to slowly disperse, blending in anonymously with the general background population. Looking at them now is like seeing a graduating class just before they all go their separate ways into the wider world, still loosely connected by their shared origin. The sheer scale of even small features in our galaxy is almost impossible for the human mind to truly grasp. We have all seen the famous majestic pillars of creation in the Eagle Nebula, looking like delicate knobby fingers of rock in a deep underwater cave. In reality, those delicate structures are colossal towers of cold gas that are roughly 4 to 5 light years tall. To put that in perspective, our entire solar system, including the Sun, all the planets, and the distant comets, could easily fit inside just one small fingertip-like protrusion on one of those pillars, with endless room to spare. We are microscopic specks living in a galaxy of giants, where even the smallest scenic details are larger than our entire known world. Billions of years ago, our galaxy may have experienced a great pause, where it almost completely stopped forming new stars. By studying the ages of thousands of stars, astronomers have found a curious gap in the galactic census, suggesting a quiet era roughly 7 billion years ago when very few new suns were being born. It seems the Milky Way took a long, multi-billion-year rest in the middle of its life, perhaps because it ran low on cool gas, before something, perhaps a merger with another galaxy, woke it up again. It is a comforting thought that even galaxies have natural rhythms of immense activity, followed by long, quiet periods of rest and dormancy, pacing themselves through the eons of cosmic time. Our entire solar system is moving towards a specific point in the sky, located in the constellation of Hercules. As we orbit the galactic center, our local path is currently carrying us in the direction of the bright star Vega, a point known as the solar apex. We are cruising towards this region at roughly 45,000 miles per hour, relative to the local neighboring stars. Of course, we will never actually arrive there, as Vega and all the other stars are also moving on their own complex paths. It is just the current prow of our ship as we sail through the local stellar sea, a fixed point on the horizon for our present million-year voyage. We can hear the shape of our galaxy by listening for the specific radio song of cold hydrogen gas. Cold, neutral hydrogen, the most abundant stuff in the galaxy, is completely invisible to normal telescopes, giving off no regular light. However, every once in a long while, the single electron in a hydrogen atom will flip its spin, emitting a very specific radio signal with a wavelength of 21 centimeters. Because there is so much hydrogen, these tiny, rare whispers add up to a constant, detectable hum that allows radio telescopes to map the grand spiral structure even through the thickest dust clouds. It is the galaxy's own signature tune, a steady, monotonous, and revealing broadcast that has been playing since the dawn of time. There are likely millions of quiet, solitary black holes drifting unnoticed through the Milky Way. When we think of black holes, we usually imagine voracious monsters actively consuming nearby stars and shining brightly with X-rays. However, the vast majority of black holes are likely completely isolated, having long ago finished consuming the material from their birth. They are now perfectly invisible, silent travelers of the dark, drifting through interstellar space without anyone ever knowing they are there. They pose no threat, as space is incredibly empty. They are just lonely, ultra-dense ghosts sailing forever through the endless galactic night, their immense gravity sleeping until something happens to wander too close. The warp in the Milky Way's disk is not stationary, but is slowly wobbling like a spinning coin as it settles. We know the galactic disk is bent upwards on one side and downwards on the other. but this warp shape is actively rotating around the galactic center. This slow precession means the up and down parts of the galaxy are gradually moving over millions of years, a majestic, rippling motion like a slow wave traveling around a stadium. It shows that our home is dynamic and alive with motion, constantly adjusting its balance as it spins, never truly perfectly still or perfectly rigid in its endless dance through the void. Paradoxically, the hottest, brightest new stars are born in the absolute coldest places in the galaxy. For a cloud of gas to collapse under its own gravity and form a new star, it must be incredibly cold, often just a few degrees above absolute zero. If it were any warmer, the thermal pressure of the gas atoms bouncing around would be too strong for gravity to overcome, and the cloud would just stay a fluffy cloud forever. It is only in the deepest, darkest, most frozen hearts of these dense molecular clouds that gravity can win the battle, crunching the freezing gas down until it ignites into a blazing new furnace. The brilliant fire of stars is directly born from the deepest, coldest freeze of the darkest places in the cosmos. In the incredibly distant future, the Milky Way and Andromeda will have merged into a single, giant elliptical galaxy, often nicknamed Milkdromeda. After the billions of years it will take for our two galaxies to slowly merge, the beautiful spiral arms of both will be gone forever. The chaotic, intricate structures will have settled down into a vast, smooth, football-shaped cloud of reddish, aging stars. This new galaxy will be a quiet, stable place, with very little gas left to form new stars. Just a majestic, unending swarm of long-lived suns orbiting a unified center. It will be a peaceful, eternal retirement for the matter that once made up our vibrant, active home. The halo of our galaxy contains incredibly rare, ultra-metal-poor stars that are almost pristine fossils from the Big Bang. These ancient stars are made almost entirely of pure hydrogen and helium, containing practically none of the heavier elements like iron or carbon that we find in our Sun. This means they must have formed very shortly after the dawn of the universe, before generations of later stars had time to forge these heavier materials and pollute the cosmos with them. Finding one of these stars is like finding a perfectly preserved woolly mammoth. They are direct living windows into the conditions of the infant universe, still shining quietly in our own galactic backyard 13 billion years later. Our Sun has completed roughly 20 orbits around the galactic center since it was born. If we think of one roughly 250 million year orbit as a galactic birthday, then our Sun is just entering its 20s, a young adult in cosmic terms. When it was born, it was on the other side of the galaxy. Since then, it has traveled the magnificent full circle 20 times, watching continents on Earth drift together and break apart, mountains rise and wear down to nothing, and countless species emerge and fade away. We are riding on a truly ancient traveler that has seen more of the galaxy than we can ever hope to imagine. Ultimately, every atom in your body was once drifting through the Milky Way as part of a vast ancient nebula. We are intimately connected to the galaxy. We are not just in it, we are it. The calcium in your bones, the iron in your blood, the carbon in your cells, all of it was forged in the hearts of long-dead stars that lived and died in the Milky Way billions of years ago. When those stars gently blew their ashes out into the void, they enriched the clouds that would eventually form our Sun and Earth. You are a very small, very complex piece of the Milky Way that has, for a brief and wonderful moment, woken up and learned how to look back at itself. Recently, astronomers discovered that we are living right next to a colossal undulating wave of gas known as the Radcliffe Wave. For centuries, we believed the various local nurseries of stars, like the Orion Nebula and the stellar clouds in Taurus, were separate, unconnected islands of creation scattered randomly around us. We now know they are actually all linked together, forming a single gigantic structure that stretches for 9,000 light-years, looking like a grand coherent sine wave gently rippling through the galactic disk. It is the largest coherent gas structure we have ever seen in our galaxy, a massive, invisible river of star-forming potential that is currently cresting right near our own solar system. We are essentially surfing on the back of this majestic slow-motion wave of future stars, riding its crest as it undulates silently through the deep dark of the local spiral arm. Our supermassive black hole, Sagittarius A star, is currently in an incredibly quiet and peaceful phase of its long life. While many galaxies have violently active cores that blaze with the light of 1 trillion suns as they ravenously consume nearby matter, our own central giant is currently fasting. It is exceptionally dim and quiet for an object of its immense size, suggesting it has already consumed most of the readily available gas clouds in its immediate vicinity eons ago. It now merely sips delicately on the occasional wisp of hydrogen that drifts too close, letting out only faint, contented burps of X-rays. It is a sleeping giant, a calm and stable anchor for our galaxy that allows life in the outer territories to evolve without being blasted by constant waves of intense radiation from a furiously feeding core. We are currently moving at breathtaking speed relative to the oldest light in the universe, the cosmic microwave background. Even if we feel perfectly still, and even if we account for our orbit around the Sun and the Sun's orbit around the galaxy, there is an even grander motion at play. The entire Milky Way is rushing through the universe at approximately 1.3 million miles per hour, relative to the smooth, ancient afterglow of the Big Bang itself. We know this because this primordial light looks slightly warmer and brighter in the direction we are headed, towards the constellations of Leo and Virgo, and slightly cooler in the direction they are leaving behind. We are all passengers on a majestic galactic vessel that is tirelessly racing across the absolute fabric of space-time, forever headed towards an unimaginably distant horizon. Deep in the spaces between the brilliant spiral arms lie the inter-arm regions, vast expanses of staggering galactic quiet. The spiral arms get all the attention because they are bright, crowded, and energetic, filled with massive young stars that live fast and die brilliantly. But between these busy cosmic highways lie immense stretches of much quieter space, the rural countrysides of the galaxy, where ancient, smaller stars drift in near total isolation. If our sun were located in one of these deep inter-arm voids, our night sky would be profoundly darker, with far fewer bright neighbors to keep us company in the dark. These are the deep, silent reservoirs of the galaxy, places of immense calm, where time seems to stretch out even longer than usual, undisturbed by the hustle and bustle of active star formation. In the early 20th century, humanity briefly believed we were at the absolute center of the entire universe, a concept known as Captain's Universe. Before we understood the vastness of dust clouds blocking our view, astronomers counting stars in every direction found roughly the same number, leading them to innocently conclude we must be in the middle of a small, solitary island of stars. It was a comforting, if incorrect, view of a cozy, manageable cosmos where we held pride of place. We now know we were just seeing our immediate neighborhood through a foggy window, mistaking the edge of our vision for the edge of reality. Our true position, drifting anonymously in the suburbs of a much vaster structure, is far more majestic, offering us a boundless ocean to explore rather than a small, closed pond. Fast-moving stars in our galaxy often create vast, unseen bow shocks as they plow through interstellar gas. Just as a ship moving across a quiet ocean pushes up a wave of water ahead of its prow, energetic stars moving rapidly through the thin soup of the Milky Way create enormous arc-shaped shockwaves of compressed gas ahead of them. These structures can be light years across, silent, invisible monuments to the star's grand passage through the dark. They are like cosmic windsocks, showing us exactly which way the star is headed and how fast it is traveling on its endless journey. They are gentle reminders that even in the seeming emptiness of space, every motion has a reaction, a ripple that spreads out to touch the wider medium of the galaxy. Our galaxy is currently being actively, though very slowly, crashed into by the Sagittarius dwarf spheroidal galaxy. This is not a violent catastrophe, but a ghostly, protracted merging that has been happening for billions of years. This small companion galaxy is actually inside the Milky Way right now, passing vertically through the disk on a long, looping polar orbit. Because galaxies are mostly empty space, it doesn't smash into us. It sails through us like a phantom, its stars mingling with ours, while its gravity gently stirs up our spiral arms. It is in the slow process of being completely dissolved by our galaxy, a majestic, billion-year-long embrace that will eventually see all its stars adopted peacefully into our own massive halo. We are part of a flat, localized arrangement of galaxies known majestically as the local sheet. Our Milky Way does not just float randomly in the void. Along with the Andromeda galaxy and our other local neighbors, we share a common orbital plane, defining a vast, flattened region of space. This sheet of galaxies is roughly moving together, bounded by immense, empty voids on either side that define our particular corner of the cosmos. It is like a grand cosmic archipelago, a chain of varied galactic islands that all share the same vast, underlying continental shelf of dark matter. We are not just a solitary point, but part of a grander, coherent landscape of structures that stretches across millions of light years. Old stars that have wandered into our neighborhood from other parts of the galaxy can be identified by their accents, just as you might identify a traveler by their unique way of speaking. Astronomers can identify tourist stars by studying the specific signature of light they emit. Stars born in the thick, chaotic central bulge of the galaxy have a richer, more complex chemical accent of heavy elements compared to the simpler, purer stars born in the quiet outer rim. When we find a star with a thick bulge accent drifting quietly near our sun in the suburbs, we know it has undertaken an epic, multi-billion-year migration to get here. It is a silent visitor from a very different part of the galactic city, passing briefly through our local streets. The Milky Way is classified as a Green Valley galaxy, meaning it is in a long, slow transition from youth to retirement. Galaxies generally fall into two broad camps: energetic, blue star-forming galaxies and old, red, dead galaxies that have ceased all creation. Our Milky Way sits squarely in the Green Valley between these two stages. It is still forming stars, but at a much more leisurely pace than in its fiery youth. We are living in the galaxy's long, comfortable autumn, a golden era where the frantic growth of summer has passed, but the deep freeze of winter is still incredibly far off in the future. It is perhaps the most stable and hospitable time in the entire life cycle of a galaxy, a perfect era for life to flourish. Vast, high-velocity clouds of almost pure hydrogen gas are continuously raining down onto the Milky Way from intergalactic space. These are immense, invisible clouds, some millions of times the mass of our Sun, that fall from the deep emptiness of the galactic halo down into the main disk. They hit the disk like slow-motion raindrops falling into a vast cosmic pond, replenishing the galaxy's supply of fresh gas for new star formation. Without this constant, gentle drizzle of fresh fuel from the outside, our galaxy would have run out of gas and stopped forming new stars billions of years ago. We are being constantly sustained by these silent deliveries of pristine matter from the deepest reaches of bordering space. The center of the Milky Way is hidden behind roughly 27,000 light-years of dust, earning it the nickname, the Hidden Zone. For most of human history, we had absolutely no idea what lay at the center of our own home. The dust is so thick along the galactic plane that visible light from the core is dimmed by a factor of 1 trillion before it reaches us. If this dust were magically removed, the central bulge of the galaxy would glow brighter than the full moon every single night, casting distinct shadows on the walls of the universe shadows and making the Milky Way a breathtakingly dominant feature of our sky. We are shielded from this overwhelming brilliance by gentle curtains of varied cosmic soot, allowing us our dark, quiet nights. Sometimes, ancient stars can gain a second youth by stealing fuel from a neighbor, becoming what astronomers call blue stragglers. In dense clusters where stars are packed closely together, an old, dying red star might drift too close to a younger companion and slowly siphon off its hydrogen gas. This fresh infusion of fuel acts like a stellar elixir of youth, causing the old star to heat up, turn blue, and shine brilliantly again, appearing far younger than it actually is. These imposters often confuse astronomers trying to date star clusters, masquerading as young stars in ancient retirement communities. They are the vampires of the stellar world, extending their own lives by gently borrowing the vitality of another. The closest star cluster to our solar system is the Hyades, forming the distinct V-shape in the head of Taurus the bull. Located just 150 light-years away, this family of several hundred stars is practically in our backyard. They were all born together roughly 625 million years ago and are currently drifting together through our neighborhood. Because they are so close, we can see their three-dimensional structure in great detail, watching them slowly disperse over time. Eventually, many millions of years from now, they will drift so far apart that they will no longer be recognizable as a cluster, their members blending anonymously into the general background of the Milky Way's lonely travelers. Every star you see is moving, but their great distance makes them appear fixed and unchanging to human eyes. We call them fixed stars because they never seem to move relative to one another in our lifetime. The constellations our ancestors saw thousands of years ago look almost identical to the ones we see tonight. Yet, in reality, they are all racing in different directions at tens of thousands of miles per hour. It is only the immense, incomprehensible distance to them that renders this frantic motion invisible to us. If we could watch the sky in super-fast forward over 1 million years, the familiar constellations would twist, warp, and dissolve as the stars flowed across the sky like fireflies in a dark summer field. There are vast, dark nebulae in our galaxy that look like holes in the sky, such as the famous Coalsack Nebula. To indigenous Australians, the Coalsack was not just an absence of stars, but the head of a giant celestial emu stretched across the Milky Way. It is actually a thick, cold cloud of dust roughly 600 light-years away that blocks nearly all the starlight from behind it, creating a strikingly prominent dark patch against the bright southern Milky Way. It is a majestic silhouette, a sleeping giant of cold dust that is currently just resting, waiting for the millions of years it will take to eventually collapse and light up with new stars of its own. Some stars in the Milky Way are rushing towards their doom, destined to fall into the central supermassive black hole. Deep in the chaotic heart of the galaxy, there is a special class of stars, known as S-stars, that orbit perilously close to the sleeping giant, Sagittarius A. These brave travelers whip around the black hole at incredible speeds, some completing an orbit in just a little over a decade, their paths tightly interwoven by extreme gravity. While most will safely continue this perilous dance for millions of years, a few are on unstable orbits that will eventually, inevitably, carry them past the point of no return. They will not die violently, but will simply fade from our view as they cross the event horizon, their light forever trapped, their substance quietly added to the immense, growing mass of the galactic anchor. The Milky Way is surrounded by an incredibly grand, spherical cloud of hot gas that stretches far wider than the visible stars. Beyond the familiar flat disk, and even beyond the scattered stars of the stellar halo, there is a truly colossal sphere of exceedingly thin, incredibly hot gas enveloping everything. This corona is so vast it may reach halfway to the Andromeda galaxy, containing almost as much mass as all the stars in the Milky Way combined. It is completely invisible to our eyes, detectable only by how it absorbs X-rays from distant quasars, acting like a grand invisible atmosphere for the entire galaxy. We are living inside a protected bubble of varying layers, with this final, hottest, and most tenuous layer marking the true, majestic boundary of our galactic territory. Our galaxy has a long bar and a short bar at its center, making its heart surprisingly complex. Recent detailed surveys of millions of stars have revealed that the central bar structure is not just a simple rectangle, but likely consists of two distinct structures overlapping. There is a thick, shorter bar that is clearly visible, and a thinner, longer bar that extends further out into the disk, perhaps misaligned slightly with the first. It is like a complex, spinning hub mechanism at the center of a vast machine, with different gears turning together to drive the grand spiral arms. This intricate inner clockwork has been ticking quietly for billions of years, slowly mixing the stars and gas in the central regions to keep the galaxy dynamic and evolving. Every time a massive star dies in a supernova, it seeds the galaxy with the heavy elements needed for future planets. The very first generation of stars in the Milky Way could not have had rocky planets like Earth, because materials like silicon, iron, and oxygen simply did not exist yet. These elements had to be forged, atom by atom, inside the crushing, fiery hearts of massive stars over millions of years. When these stars reached the end of their lives and gently blew themselves apart, they scattered these new, precious ashes across the interstellar clouds. Our planet is literally built from the recycled debris of these ancient, long-dead stellar giants, a beautiful inheritance passed down through generations of stars, to eventually create the solid ground beneath our feet. We can use the gentle pulse of specific dying stars to measure the exact shape of our galaxy. Scattered throughout the Milky Way are pulsating stars known as Cepheid variables, which brighten and dim with a perfectly regular clockwork rhythm. Because this rhythm is directly related to their true brightness, astronomers can use them as precise cosmic lighthouses to measure exact distances across the vast dark. By patiently mapping thousands of these pulsing beacons, we have been able to trace the subtle warp of the galactic disk and the exact curve of the spiral arms, even though we cannot see them from the outside. They are the galaxy's own internal measuring tapes, ticking quietly away in the dark to help us understand the grand home we live in. There are orphan clouds of star-forming gas that exist completely outside the main galactic galaxy. Hovering in the lonely emptiness of the galactic halo, far from the crowded disk, are mysterious, isolated clouds of cold hydrogen that seem to be trying to form stars on their own. These lonely nurseries might have been ejected from the main galaxy eons ago, or perhaps they are pristine leftovers from the galaxy's formation that never fell in. They are quiet, solitary outposts of creation, struggling to light up a few small stars in the deepest, darkest outskirts of the Milky Way. They remind us that the urge to create is present everywhere in the cosmos, even in the loneliest and most unexpected of places. The Milky Way is rotating differentially, meaning the inner parts spin much faster than the outer parts. Unlike a solid vinyl record that turns all together, our galaxy is fluid, with different regions moving at different speeds, depending on their distance from the center. Stars closer to the core have much shorter distances to travel and whip around relatively quickly, while those of us in the outer suburbs take a far more leisurely path. This difference in speed is partly what winds up the spiral arms, stretching grand clouds of stars into beautiful, curving ribbons over hundreds of millions of years. It is a grand, shearing flow that keeps the galaxy mixed and dynamic, ensuring that no part of it ever truly remains stagnant forever. Our galaxy likely has a forgotten sibling that was consumed so long ago we can barely find traces of it. Astronomers believe a massive galaxy, perhaps a quarter of the size of the Milky Way, merged with us very early in our history, roughly 10 billion years ago. This ancient collision, sometimes called the Kraken merger, would have drastically reshaped the young Milky Way, puffing up its central bulge and scattering its stars. Today, this lost sibling is completely gone, its stars so thoroughly mixed in with our own that it takes incredibly detailed detective work to identify them. It is a silent ghost in our galaxy's machine, a major part of our ancient history that has completely dissolved into the grand structure we see today. In the spaces between galaxies, there is a faint, diffuse glow, known as the intergalactic sea of stars. Not all stars stay within their home galaxies. Over billions of years, gravitational interactions can gently nudge countless stars out into the utter void between the massive islands. These lonely wanderers form a fantastically thin, almost undetectable mist of light that pervades the space between the Milky Way and Andromeda. If you were floating in that endless dark, you might see almost nothing but utter blackness, yet you would still be surrounded by extremely distant, solitary suns. They are the ultimate exiles, drifting forever in the deepest ocean of the night, far from any shore. The Milky Way is not just a flat disk. It has a distinct peanut or X shape at its very center. If we could view our galaxy from the side, the central bulge would not look like a simple sphere. but would have a slightly pinched, boxy shape, resembling a peanut in its shell. This strange shape is a natural result of the complex orbits of billions of stars in the central bar, which tend to buckle and puff out over time due to gravity. It is a common feature in older barred spiral galaxies, a sign of cosmic maturity that adds a touch of unexpected, whimsical geometry to the grand, serious architecture of our galactic home. Our galaxy is constantly breathing, with gas rising up out of the disk and then raining back down in a vast cycle. This process, known as the galactic fountain, is a majestic, slow-motion circulatory system that plays out over millions of years. Supernovae in the disk heat gas and blast it high up into the halo, where it slowly cools, condenses into clouds, and then gently rains back down onto the disk like a cosmic drizzle. This endless cycle redistributes heavy elements from the busy star-forming regions out to the quieter suburbs, ensuring that the materials for life are spread evenly throughout the galaxy. It is a slow, steady, deep breath that has been keeping the Milky Way healthy and fertile for eons. The spiral arms of our galaxy are not permanent structures, but are constantly forming, dissolving, and reforming. We tend to think of the spiral arms as enduring features, like the bones of a skeleton, but they are more like transient waves on the ocean. Computer models suggest they might be temporary patterns that emerge, last for a few 100 million years, and then fade away, only for new patterns to emerge later. Our current beautiful four-arm spiral might just be a passing phase in the Milky Way's long life, a fleeting expression of its current gravitational mood. It is a wonderfully fluid, dynamic view of a structure that seems so solid and eternal from our brief human perspective. There are regions in our galaxy where the density of stars is so low, you might not see another star for hundreds of light years. Far out in the desolate rim of the galactic disk, or deep in the emptiest voids between the spiral arms, lie the loneliest places in the Milky Way. If you lived on a planet in one of these regions, your night sky would be almost completely black, with perhaps only one or two faint, distant smudges of light visible to the naked eye. It would be a profoundly solitary existence, a silent, velvet darkness that would make the universe feel incredibly empty and vast. These quiet deserts are the counterpoint to the bustling, crowded cities of the galactic core. We have discovered thousands of other planetary systems in our small corner of the galaxy, suggesting billions more exist. For centuries, we wondered if our solar system was unique, a solitary miracle in a sterile universe. In just the last few decades, we have found that planets are incredibly common, with nearly every star likely hosting at least one world. The sheer variety is staggering. Worlds with two suns, worlds made of lava, worlds that are giant water oceans, and worlds that might be eerily similar to our own. We now know that when we look at the Milky Way, we are not just looking at stars, but at a practically infinite library of other worlds, patiently waiting for us to read their stories. The chemical composition of our galaxy is slowly changing, becoming richer in metals over time. In astronomy, any element heavier than helium is called a metal, and the universe started with almost none of them. With every generation of stars that lives and dies, the overall percentage of these heavy elements in the Milky Way very slowly increases. It means the galaxy is evolving chemically, becoming more complex and fertile as the eons pass. The stars forming today have far more raw material for building rocky planets and complex life, than the stars that formed 10 billion years ago. We are living in a wonderfully rich, chemically diverse era of the galaxy's deep history. Our galaxy is not perfectly centered within its own dark matter halo, but is slightly offset and moving. Just as a yolk might not be perfectly centered inside an egg, the visible disk of stars and gas seems to be sloshing slightly back and forth within the massive invisible bowl of dark matter that holds it. This might be due to the gravitational tug of the passing Magellanic Clouds, which are massive enough to disturb our galaxy's equilibrium. It paints a picture of a dynamic, jelly-like system that is constantly reacting to its environment, wobbling gently as it sails through the cosmos, rather than being a rigid, unyielding structure of stone. Eventually, every single star in the night sky will burn out, and the galaxy will go dark. It is a thought that seems sad at first, but it is just another part of the grand natural life cycle of the cosmos. In roughly 100 trillion years, a time so vast it is totally incomprehensible, the very last red dwarf star will finally exhaust its fuel and fade to black. The Milky Way will then be a vast, silent graveyard of cold, dark, stellar remnants, circling endlessly in a universe that has grown impossibly large and empty. It is a reminder to cherish this incredibly brief, bright, and beautiful era of starlight that we are lucky enough to be conscious in right now. An empty space in the galaxy is seething with virtual particles that pop in and out of existence. According to quantum physics, a perfect vacuum is impossible. Even in the deepest voids between the stars, space is alive with fleeting energy. Tiny pairs of particles are constantly borrowing energy from the vacuum to appear for the briefest fraction of a second before annihilating each other and vanishing again. It means there is truly no such thing as nothing in our galaxy. Everywhere, always, there is a fundamental simmering potential, a quiet, microscopic froth of creation and destruction that forms the very bedrock of reality itself. And so, our journey through the majestic and boundless world of the Milky Way comes to a gentle close. We have sailed together tonight across an ocean of 200 billion suns, drifting from the crowded, glowing heart of our galactic city to the quiet, lonely outposts on the very edge of the deep dark. We have seen that what looks like a simple, hazy band of light in our night sky is actually a magnificent, incredibly complex tapestry woven from ancient star clusters, vast sleeping clouds of dust, and the quiet, invisible scaffolding of dark matter that holds it all in a gentle, gravitational embrace. It is a place of almost unimaginable scale, where even the most tremendous cosmic cataclysms fade into silent, beautiful ripples by the time they reach our safe and distant shores, allowing us to witness the grandeur of creation without ever feeling its untempered fury. As you rest now, remember that you are not merely looking up at this vastness. You are cradled safely deep within it. The exact same gentle gravity that keeps the glorious spiral arms turning in their billion-year cycles is what holds you securely to your bed tonight. You're a traveler on the grandest ship in the universe, a vessel of light and mystery sailing silently through the unending void. There is nothing more you need to do now but rest, letting the colossal, slow-turning wheel of the galaxy carry you effortlessly through the night, just as it has done for every night since the Earth was born. If you happen to still be awake, that's just fine. The story will still be here when you wake, patient and timeless. But if your eyes are heavy, let the stories of the Milky Way carry you gently into rest, Sleep well. Good night.